Let's look at this problem. We're going to use differentiation to find the maximum volume of a box. The question says, calculate the maximum volume of an open top box that is to be manufactured from a 3 meter by 3 meter sheet metal. Alright, so let's see something here. Suppose this is our sheet metal, right? Okay, 3 meter high, 3 meters wide, sheet metal. Now, when we're going to form the box, we're going to have to cut off this end here, cut off this end, cut off this end, cut off this end, to fold the edges, right? So if we do that, we cut these off, cut these off, cut these edges off, cut these edges off. Now, when we fold it, we're going to have to fold it along here and here. So this would be the bottom of the box, and you have side, 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 side. So what would the final box look like? We'll be looking at the top of the box here, right? And then, oh, by the way, these sides would be reduced, but it wouldn't be 3 meters anymore. So let me rub off the 3 meters for a while. Now here, the box. We have it folded along here. All right. So the folding would be along these green lines, right? All right, so that's what we have. So now, this would be the height, h. Let's call this h. We have the height h here, h here. So here now, this would be 3 minus h, because remember, all the way from top to bottom was 3. But now we cut off h and cut off another h. It's 3 minus 2h. So this height now here would be 3 minus 2h. This now would also be 3 minus 2h. We have 3 minus 2h. Alright? Remember, this is h, this height is h, this is h, this is h, because we're folding it. Alright, so now we have height h. This would be 3 minus 2h long, 3 minus 2h wide. So the volume, remember how to calculate the volume of a box now? The volume of the box would be the length, 3 minus 2h, times the width, 3 minus 2h, times the height, h. We're saying length by width by height. Alright? So, if we multiply out those, we get 3 by 3, that's 9. 3 by negative 2h, that's minus 9, 3, 2, 6h. Then 2h times 3, that would be minus 6h again. Negative 2h times negative 2h, 3 plus 4h squared. And all of that times h. So what do we get now? If we multiply by h, that would be 9h minus, oh, you see this negative 6 minus 6, so it will be negative 12. And negative 12 times, negative 12h times h would be negative minus 12h, right? Plus 4h squared by h would be 4h cubed, all right? Let's write it this way. V equal 4h cubed minus, this was what? H squared. This would have been 12h squared. This here would amount to negative 12h, and then h times it would give you 12h squared, alright? So here now, this would be 4h cubed minus 12h squared plus 9h. So that's what you have. Now we want to maximize the volume. You notice this thing, is a cubic equation. So if we could look at it and find out where a local maximum point occurs. Suppose we plot a graph of it. Let's use GeoGebra. It's 4h cubed. Well, in GeoGebra's case, it's 4. We have 4x raised to the power of 3. 4x cubed. I'm typing it, but you can't see the typing. Minus 12x squared. Minus, we have minus 12x squared. Let me just thing there. Let me adjust it so you can see everything. Alright, so I'm typing in the function 4x to the negative 3 to the 3 minus 12x to the 2. What else is here? Plus 9x. It says h, but in our case is x. Alright, there we have a graph of it. That is what the graph of that function would look like. Alright, we have a maximum point at, you see, like 0, 0, and a minimum point at negative 14. But let us see what happens here. If we find the derivative dv by dh, we're going to get 4 by 3, which is 12h squared minus 2, 12, 24h plus 9. Right, remember, you have to practice your differentiation to see exactly what's going on. Now, here, we would, without the graph, we would have to do this to find the maximum and minimum points. Here now, we have 12h squared minus 24h plus 9 equals 0. We have to equate it to 0. Suppose we divide by 3 to get smaller numbers. We'd have 4h squared, because 3 into 12 is 4, minus 3 into 24 is what? 8. 8h plus 3 into 9, 3 equals 0. Let's solve this equation. Could it be solved using factorization? If we multiply 4 by 3, we get 12. Find two numbers that multiply to give 12 and add to give negative 8. Yeah man, negative 6 and negative 2. Negative 6 times negative 2 gives positive 12. Negative 6 minus 2 is negative 8. Alright, good. Do it by factorization. You could do it using the formula or completing the square too, but we do it by factorization here. So you have 4h squared Let's split up the negative 8h into negative 6h and negative 2h. Minus 6h minus 2h plus 3 equals 0. Let's factorize now. The common factor here is seem like 2 and h. So we have 2h outside the bracket. 2 into 4 goes 2 times h into h minus 2 into 6, 3. Alright. Minus, what's the common factor? 1. Negative 1 into negative 2h is positive 2h. Negative 1 into 3 is negative 3 equals 0. So the common factor that we have here now is 2h minus 3, 2h minus 3. So let's put the 2h minus 3 outside the bracket. And inside the bracket we have 2h minus 1 equals 0. So when these things multiply and give you 0, it means it's either 2h minus 3 equals 0 or 2h minus 1 equals 0, or both equals 0. So 2h minus 3 equals 0. H would be what? H would be 3 over 2 when you work it out. And if 2h minus 1 equals 0, then h would be a half. Right. So you have two turning points, or two critical points, stationary points. One is at h is 1.5, the other one is at h is half. Was that what happened here? Let's see. One of them. Let's see what happened here. We have 4h cubed minus 12h plus, we have here 4h squared minus 8h plus 3. What does this say? 4x squared minus what? Minus 8h. Alright, it would be 4x squared minus 12x plus 3. 4x squared minus 12 plus 3. Plus 3 it should have been. I have to adjust the graph. Something went wrong. I made a mistake here. I have to adjust the graph. Alright, good. Now I also want to increase the size of the graph. Alright, there we have our graph. We made the corrections. Where are the stationary points now? Is 4x squared minus 12x. 4x squared, no, 4x. What we had, originally, it was 4h cubed. Oh, my. 4h cubed. The original function is 4x cubed minus 12x squared. Minus 12x squared. Plus 9x. Am I making so many mistakes with this thing, man? Right? It would have been 4x squared minus 12x plus 9x. 4x squared minus 12x plus 9x it should have been. Am I? Yeah, that was it all along. Keep making one mistake after another. But that was it. Yeah. So we can see it now. Two turning points. One is at half, the other one is 1.5. Right, now we got it. Right? This was kind of confusing. But anyway, if we don't use the graph, we would still get the turning points, 1.5 and half. So the height is either 1.5 or half. Now, let's see what the volume would be when h is 1.5. Now remember, the volume has the formula for h cubed minus 12h squared. Let's rewrite it down here. Volume equal 4h cubed minus 12h squared. So it's 4h cubed minus 12h squared plus 9h plus 9h. Alright, good. So the volume 1 is 4 times 3 over 2 cubed minus 12 times 3 over 2 squared plus 9 times 3 over 2. We're going to test both and see which one works. Both values, see which one works. So where is my calculator? Calculator. This is the one I want to use. Alright. So 3 over 2 equals, alright, 1.5 times 1.5 times 1.5. That's same as 3 over 2 cubed equals times 4 equals, alright, good. That minus 12 times 1.5 times 1.5. That is minus 12 times 1.5 squared. Same as 3 over 2 squared. Equals, alright, plus 9 times 1.5 equal. Alright, so we get 0. Now, that is a 0 at 3 over 2. Now look back at the graph. You notice at 3 over 2, which is 1.5, we have 0. Now, it's impossible for us to have the h at 0, because what happened? And make a box, because what happened? When we have the height at 0, it means we have just have the metal, we didn't make the box. We have the sheet metal, the square metal. We didn't fold anything, that's why the height is 0. So, let's try now with h equal half. Now things will work out and we see what the volume is. The volume 2, the volume at half, right? Well, we could just cross out this volume and say this volume equals 0, which is not the volume we want. Now the volume that we want is 4 times half squared, call it 0.5, cube, since we're going to use a calculator, minus 12 times 0.5 squared plus 9 times 0.5 equals, or we could just put equal here, we have some space over on the right, so let's just put the volume over there. So, calculator. So, what I really would want the calculator to be shown on this side. But do we have a calculator? I think we have a calculator in this thing, We could also use this calculator. Where is it? Calculate. Alright, let's not bother with that. 4 times 0.5 cube. We have 4 times 4 times 0.5 times 0.5 times 0.5 equal. Right. Because half cube would have been 1/8. And by the way, let us just work it out with a fraction. Since the calculator is not showing up on the screen. 4 times half cube, right? Minus 12 times half squared. Plus 9 times half is 9 over 2. Half cube is 1/8, So it's 4 times 1/8. minus 12 times half squared is what? A quarter plus 9 halves. So what we have here is the volume equal 4 times 1/8 is 4 over 8 minus 12 by a quarter is 12 over 4 plus 9 over 2, 9 halves, right? If you do your fraction, if you remember your fraction and the common denominators, we have 4/8 minus, multiply this by 2 and we get 8, so it's something over 8. If you multiply this by 2, we get 24. 12 2 is 24. Alright, plus we multiply this by 4 and we get something over 8. If we multiply the 9 by 4, we get 36. So we have 4/8 minus 24, 8 minus 36, 8. Give us how many? 8s. So we might as well say 4 minus 24 plus 36 is what? 4 minus 24 plus 36. Was it that? 4 minus 24 plus 36, right? 4 minus 24 plus 36 equals 16. So that gives us 16/8. And what is 16/8? That is 2. The volume is equal to 2 cubic units. So we have to make the height half. And the volume will be 2. Well, guess what? When you look at the graph, what do you see here? The volume is 2. So you could have used either the graph or differentiation. But I use both of them. But if they ask you to use differentiation, you just have to use it, right? To optimize that problem. Optimize the volume of the box. The dimensions of the box would be what now? What would be the dimensions of the box? If the height is half, then the dimensions will be what? 3 minus 2 by half. 3 minus 2 times half would be 3 minus 1, which is 2. So it is 2 by 2 by, the height would be half. 2 2s for the dimension, the volume would then be 2 by 2 by half, would be 2 2s 4, 4 by half would be 2. Alright? So the volume would be 2 cubic units. You'll have to make the box 2 wide, 2 long, and half high. So how you would cut out the thing there, how you would cut out the shape of the box would be 2, 2, this would be half. So you cut off half here and half here. Cut off half and half. Half and half. Half and half. And then you fold it. Alright? Anyway, I'll see you in the next video.